Okay, so in a previous video, we looked at the Olsen model for bushfire fuel accumulation. So we had leaf litter falling from trees, landing on the ground, and then rotting away or decaying. And this X is, or this is the rate of fuel accumulation. We thought that after a fire, all of this material was burnt. So at time zero, when we start reaccumulating fuel, there's none to begin with. That means initially that there's no decaying fuel. So the first modification is the initial condition. Suppose that a fire hasn't been that intense and not all of the fuel has been consumed. This doesn't actually change the form of the model, but it does shift the model solutions. You'll know that you can solve this model. This is just a separable equation. It has an exponential solution. So this will just shift the solutions up or down in space. Or it'll just change which one of the general solution family that we're looking at. The second modification is trees aren't going to constantly drop material. They're going to drop material sporadically. You may have noticed that eucalyptus trees shed their bark seasonally. So there's obviously going to be some periodic variation in time of this litter accumulation. So that is it's often called seasonal. People that work in modeling and particularly time series statistical modeling call this sort of thing seasonality. So if you want to have a periodic or seasonal L term, that means that you rewrite your model dx dt equals some constant L naught times a periodic function. Let's say it's got frequency omega, it's got some phase shift phi, and let's say that k is still the same. So that's the first that's a modification to the L, and of course you can modify k as well. One can argue that decay will occur more rapidly when the fuel is wet, or the fuel litter layer is wet. It will possibly rot faster. It's going to be wetter when the weather's colder, so that means it's seasonal in winter, or it's more likely to be exacerbated in winter. So you have periodic, these are functions of time now. So you might write as your finally modified Olsen model K naught now I'll call this one omega 1 and phi 1. And then the omega associated, the frequency that K changes at, could be different. Okay. What one would have to do is appeal to data. You would have to actually go out and measure fuel accumulation and measure the rate at which it accumulates to estimate all of these parameters. Okay, so hopefully that gives you a bit of an insight into how modeling happens. You often start simple and try and build up from there. And you make some fairly crude hypotheses at times, and you try and shoehorn them into your model as best you can.